Hello, my name's Carl Irwin, and this is a quick tutorial covering the OpenGL rendering process that I've been following lately. If you've been watching anything on my YouTube channel, you see that I've had a few recent video posts that are employing the OpenGL rendering option in Blender for final render, and a couple of you have asked exactly how that works and how you might utilize that. So this is just kind of a quick look at how that process would work. First of all, before we get into it, I want to explain that OpenGL rendering is something that's been in Blender for quite some time, and it's not really anything new. It's just that the OpenGL render has traditionally been used for just sampling your animations, just demoing your animations, and it's just a render platform used for checking your animations and making sure that everything flows properly. It's kind of a low resolution, low textured form of rendering. It doesn't have any effects on it like motion blur or anything like that. Just used for checking your animations to make sure that they're properly set and natural and flowing and whatnot. Now, with the advances in texturing in OpenGL, OpenGL rendering looks much better than it used to. In fact, you can do a great deal with the textures in the viewport using what's called GLSL shading, and we're going to talk about that in a second. And it gives you some pretty convincing OpenGL renders if you use it smartly. So let's take a look at this example. This is one of the recent videos that was on that I put up on my YouTube channel. It's a video of the Empire State Building, and you can see this is how the scene is set up. We have the model of the Empire State Building here. There's another model that's duplicated a few times of a couple of other buildings, and then there's one more skyscraper right here. Right now, if we go back to camera, right now you can see how the animation works. So there's 200 frames of animation, the camera's panning out, and you can see the parallax motion between the Empire State Building model and these other models here that are behind the main building in the front. Now you see that there's a big plane back here, and on that plane, we'll take a look at that in a second, is a picture, a photograph that was taken from the observation deck of the Empire State Building of the New York City skyline. And what we're doing is we're blending in these buildings in the front with that photograph. So let's take a look at that real quick here. Right now we're in solid mode, and I want to point out this is how OpenGL rendering works in terms of getting a realistic appearance. You need to use GLSL shading. So if you open up your properties panel on the right hand side and look underneath display and enable GLSL, by default multi-texture is set, so you need to change that to GLSL. And one quick note about that, this should work with NVIDIA cards, and it's not typically working on most systems that have ATI Radeon cards. Now the strange thing is that this computer, which is not a very powerful computer at all, it's just a laptop computer with a dual-core processor, and it has only about 4 gigs of RAM, just kind of a typical off-the-shelf Walmart computer for a couple $100, HP laptop. This has an AMD Radeon graphics card, and apparently my drivers for this card, I'm using Xubuntu 12.04. Apparently my drivers are functioning properly enough to utilize the 3D OpenGL capabilities of this card in Blender. So I guess I lucked out. You may not be so lucky if you're not using an NVIDIA card, so you'll just have to try this and see if it works. Anyway, you want to set it to GLSL, and right now we're going to turn on textured solid. and you'll see, give this a second, these textures will pop up and you can see what those textures look like. Let's go back to the camera view. You see the background picture blends in quite well with these other buildings that we've placed in front. But this doesn't really give us the proper lighting. We want to go to texture mode. So we'll go to the viewport shading and click on texture. And now you can see that the lighting is a little bit better in this situation here. One quick note about lighting. In GLSL, you do not get soft shadowing. So what you need to do is set up an array of lights that will, sun lamps like these up here that are pointing in slightly different angles, and the combination of those lamps will give you some softer shading. If you've ever visited Andrew Kramer's website, videocopilot.net, you'll see that he has a number of tutorials on there, mostly for After Effects, Adobe After Effects, the compositing software, but he also has some tutorials on there for 3D programs, like 3D Studio, Cinema 4D, and I know he's done some work in Blender in the past, but he's got one old tutorial on there about creating soft shadows inside of a 3D program, and the idea is this same idea that you need to have an array of lights to get multiple hard shadows that when combined together you get a soft shadow. So that's the idea here. You need to light very, very carefully when you're using GLSL and using that for render output. Now in terms of rendering OpenGL, if you look down here in the right hand where the cursor is at, you see two buttons. One of them is a camera and the other one is a slap plate, a time plate that you would use for making a movie and setting the time and the audio sync to your cut. You know what I'm talking about. These are render buttons, and they look just like the render buttons that are over here in the internal render. However, these buttons control the OpenGL render capability. So let's click on the camera one. We're going to get a single OpenGL frame, and you'll see it only takes a couple seconds and we have a fully rendered frame there, and it's really not that bad. It looks pretty good. The textures look pretty clean. You'll notice that you do have one issue here where you see the lines from the lamps showing through, and we want to get rid of that. You can see over here down in the corner that you can see the green outline of the selected object. We want to get rid of that. So what we'll do is we'll go back to 3D viewport, and another thing I want to point out is this little selection here, backface culling. If I turn that off, you see these black parts that show up? These are places where the texture is on the other side of the mesh and it's not showing up in a GLSL. So in order to see everything, you need to turn on that backface culling, and you'll see the textures showing through, or you'll see through it to the other side. So that is something that you need to use when you're doing OpenGL rendering. Anyway, in order to get rid of these guidelines here, we need to select under Display this selection that says Only Render, and when you click that, it will turn off all of those guidelines so that you're only looking at the things that will be rendered in the final output of the scene. So let's try this again. We'll render one frame of this and we'll give it a couple seconds. Again, it's only a couple seconds and you get a fully rendered frame, and it's pretty good quality that you get with this OpenGL rendering. You see all these textures nice and clean. The shadows look pretty good. It's a little bit cartoony, but we're going to do some things about that in compositing later on. You can, of course, color correct this. Will help to make everything flow together. Now, one quick note about the animation. If you look closely at the animation, you'll see that these buildings here are somewhat necessary to create the parallax effect when the camera is moving out, where you can see behind in some moments, and then as the camera moves, these buildings in front will occlude your vision, or you can see places where the buildings are in front of the background, and as the camera moves, the background comes into view. So what's happening here is your eyes are being tricked into believing that the 3D space continues off into the distance because of the parallax effect that's occurring with these buildings up in the front. So we're just kind of playing this cheap trick that makes it appear as though there is 3D depth when there really is not. If you didn't have these little buildings here, these couple of buildings, this effect probably would not work. So this is kind of a necessary addition to make this work out. Okay? Now, one issue is that you do not have motion blur in OpenGL rendering, so we need to do something about that. Now, one thing that you can do is you can render out your sequence by clicking on this button here. You render an image sequence, and all of your information that you have set over here in the internal render settings will apply to the output of your OpenGL render. For example, your resolution, the frame range, the frame rate, and also your output location. So you can set your output location for a folder, and also the format. You would want to set this to PNG. Right now it's set to AVI because the very last render that I did on this from the video sequencer was a video file. But you always want to render in frames, individual frames, PNG frames, because if your render fails halfway through, you can still salvage the frames that were rendered properly and then just render from that point where everything fell apart. If you use a video file for a long render and something happens in the middle, the file's corrupt and it's unusable. So always render to PNG single frames first before you decide to render out the full sequence in a video format. Anyway, set your output, and you'll also notice that there is this sampled motion blur option. This does not work with OpenGL. This works only with the internal render, Blender internal render engine. So that's completely useless. You can turn it on, it won't do a thing, it won't give you any motion blur. So how do we get motion blur? Well, there's a couple of ways. One way is to render out your sequence and then import it into the compositor and apply vector blur from the render output, render layer from the scene. So that's one way to do it after you've rendered out your image sequence. That works pretty well in simple scenes. However, we all know that the vector blur has a tendency to create artifacts that are undesirable on occasion. So that's not the best way to do it. Now, the way that we're going to apply blur, motion blur, is by creating our poor man's sampled motion blur. We're going to create subframes that we can composite together to create blur on the main 200 frames of our animation. So here's what we need to do. We need to end up with more frames than 200. Okay, within the space of our animation, we need to get more than 200 frames. So the way that we do that is over here we increase the frame range. So let's increase that to 300. So we're going to increase it by a factor of 50%. So we have 150% of the original frame rate. Okay, so 300 frames instead of 200. You see it extends out our animation bar down here. We have 100 more frames than what we started with. We're going to then look down here at this section called time remapping. And what we want to do is we want to cram the 300 frames into the space of the 200 frames that we have for the keyframed animation. And the way we do that is we look at time remapping. There's a side that says old mapping value, and then there's a side that says new mapping value. And we want to change the new to 150. And you can think of this in terms of percent. Okay, percentage. We are increasing it sort of in speed by 150%. Now you can see what happens here if I click back to the beginning of the animation. Here's the first frame, and if I click right to the end of the animation, you can see that the cursor stops at frame 200 even though I have 300 frames. What it's doing is it's cramming 300 frames into the space of 200. So if I render this out, I'll get 300 frames, but within these keyframes at 200 frames. So I'm ending up with more frames in the animation. I'm ending up with subframes greater number of frames than what I would normally have if I just rendered this out without changing the time remapping and the frame range. Okay, so what you would want to do is set your output folder and render this. And once you've rendered it, I'm not going to hit that because I've already done it. Once you've rendered it, you'll go to the video sequence editor. So let's go to the video sequence editor. We're going to, this is from the final output of the last project I did. We're going to just delete these tracks here. Hit X to delete, X to delete. Now what we want to do is we want to import that render that we just put out, the 300 frames. But I want to fix my time remapping. We're going to set this back to 100. So we're using all 300 frames here. Okay. Now we're going to click Add. And we will go to Image. And we're going to navigate to our folder with those images in it. So here's our folder. And you can see that there are indeed 300 frames here. I will hit A to select all, and I'll hit the start. I'll change the starting frame to 1, and we'll click Add Image Strip. And now you can see here's our animation that we just rendered out a few minutes ago. Okay, so this is just a straight up OpenGL render. You can see how all of the edges are really hard because there's no motion blur there. Okay, we're going to do something about that. So what we're going to do is we will take this image strip and we're going to duplicate it. Shift D to duplicate. We'll move it up one layer and we're going to slide it over one frame to the right. So we'll move it so that it's starting at frame 2. And we'll leave it right there. Now we're going to go over to the Properties panel and we're going to change the opacity to 0.3. Now you can use whatever you want as long as this is transparent to a certain degree. You want it to be somewhat transparent, translucent, so we can see through it. Okay. Now you can see what's happened here. If I turn this layer off, you see that hard line, that hard edge from the strip underneath. When I turn it on, you can see now I have two samples. So I can see through one sample to the one underneath. And I've created 2 samples of motion blur. Because we already have our animation. You can see the camera motion in these frames that are offset, and that is essentially what sampled motion blur is. So I'm going to do this a couple more times. We will duplicate this one more time. We'll move it up, slide it over to the right. Now, one thing is that you want to be very careful with this technique. I'm going to lower this opacity a little bit more to 0.2. You want to be careful with this technique because if you use too many of these layers and you haven't created enough samples, we're already oversampling it because we didn't have more than twice the number of samples. We didn't create 400 frames. We only did 300. So we have to be careful. If you do too many of these, you'll end up with just a blurry image. It won't make any sense. It just looks like everything is blurred. Okay, you want to have only a few samples here so that it looks like it's motion blur and not just a blurry picture. So now we've got 3 samples. Let's do this again. Create another one, slide it up, move it over one frame, set the opacity to 0.1. And I'm going to do one more, but this one we're going to slide to the left to frame 0, which is actually one frame behind, ahead of the first strip. And we're going to set the opacity way down to 0.05. Okay, and that'll give us one leading sample. It's just a very light sample that's slightly ahead of the main sample that's on the first track. Okay, so here we've got a somewhat of a convincing motion blur. You can see as we scroll through this, you see what we've created. Okay, we have created a poor man's motion blur. So what you would do at this point is you would render this out again, all 300 frames, and you don't need to hit the OpenGL button. You can actually at this point, as long as your post-processing in the render settings is set to sequencer, you can just render this using the internal render engine. Because we're only rendering these strips, it'll only take a couple of seconds per frame anyway, so you might as well just use the internal render rather than use the OpenGL. You want to set a new folder, so you're rendering this out to a new folder, all 300 frames, and you would render this. Okay, so let's say that we've rendered it, which I did earlier, and let me delete all of these. We'll go to the next step. Now we've got 300 frames of animation with motion blur. But the problem is that we need to have 200 frames at 24 frames per second. So we need to speed up the animation that we have until we get it to that equation, that 200 frame equation. So let's find that strip that we just rendered out, and we will import it. So again, there's 300 frames here. We will hit A for all, start frame 1, and we will click Add Image Strip. And here's our image strip, and you can see if we zoom in, you can see the sampled motion blur that we created. Okay. Now the final step here, in terms of getting this back to the correct output length, is to speed up this clip. So what we're going to do is we're going to select the clip, click Add, go to Effect Strip, and select Speed Control. We're adding a speed control layer. So go over to the properties of the speed control layer, and we're going to check or uncheck Stretch to Input Strip Length. We'll turn that off. We want to leave Use as Speed selected, and we're going to change the speed factor to 1.5. We want to increase the speed by 1.5, by 50%. Okay, so we're undoing what we did earlier with the time remapping. And you can see what's happened here. As I scroll through the animation, once I get to frame 200 and I go past that, you can see there's a freeze frame. That's because the animation has been sped up and it ends now at frame 200. It's back to where it was before. And what I want to do in my render output is I can change my frame range now from 300 to 200, because that's where my animation stops. Okay, so now I have corrected the time, and you can see that our sampled motion blur is still there. And what will happen is when I render this out, it will drop all of the frames that I don't need, and it will leave only the frames that I do need to get me my 200 frames at 24 frames per second. Okay, now I know what you're thinking. You're probably thinking that this is quite a process. It seems like an awful lot of work for just one final rendered out clip. It seems like you would be saving just as much time by just using the internal render. Well, let's think about this for a second. The internal render in this scene, when I tried it, took about a minute to a minute and a half per frame to render, whereas OpenGL only takes a couple of seconds per frame. And each time I render this, you're talking about only a couple of seconds per frame. Believe me when I tell you that you can do all of these steps and you end up with a final result in a fraction of the time as you would by just setting the internal render and letting it run. You end up with a final product much quicker, and something that you can work with in the compositor much quicker by using this OpenGL method. So that's the idea, is to render things much faster. Now, as far as texturing goes, there are some limitations, but there's also some big advantages. In OpenGL, you can use, if we click over here on the texture, or the material tab, you can use nodes. You can use shader nodes to create more complex textures. And those textures do show up in OpenGL. So you can add vector paint, and you can paint in a fake ambient occlusion, and you can use nodes to create that, and it will update in real time, and it will show in GLSL, and it will render in OpenGL. You can even add a texture that has maybe an image of an environment and set it as reflection. And you can make reflective materials that will render in OpenGL. Now, they're not truly reflective materials because they're not really reflecting anything in the scene. But much like all of the other compositors that are out there that are now employing OpenGL and have methods for creating false reflection, you can do much the same thing right in Blender and render out using GLSL and OpenGL rendering. It will also honor alpha transparency in OpenGL. The problem is that it really only works with, it works well with, I should say, 1-bit alpha. So that is that the alpha is either transparent or it's completely opaque. It's one or the other. If you have an alpha transparency in a material that is gradient, that is, that it is transparent and then slightly transparent and translucent and slightly opaque and then finally completely opaque, that does not render very well. The only way that that works is if you're rendering only one material against the background in your scene, and that will render out the alpha transparency in a gradient format. If you have more than one object and they're rendering on top, or rather they are placed on top of other objects in the scene or in the foreground of other objects, it will not work. There is a workaround, however. I've discovered that if you create multiple copies of your scene and just render out each scene with one object at a time against the background, you can create assets that you can then composite later on, and you can still render those things out OpenGL and get that gradient texture. So there are some workarounds for that too. But anyway, that's essentially the technique that I've been using lately, and I know some of the results look pretty good. Some of them don't look all that great. It's kind of a work in progress trying to figure out how to best use this. But I'm pretty impressed with the ability that Blender has to render in OpenGL and get some pretty believable results. One quick note about these models. I got these models from the Google SketchUp warehouse. It's actually a Google product made by a company, I think the company's called Trimble SketchUp. And SketchUp is a free 3D modeling program that you can, most people use to create inanimate objects like buildings and architecture and vehicles like aircraft, you know, a giant Boeing 747. You could model something like that in SketchUp. And people put these models then on the warehouse website, and they're available for people to download and to share. That's where I got all of these models at. So I downloaded those and I used them in SketchUp, exported them to a file format that I could use then in Blender. So that's something for you to maybe experiment with and play around with. That's pretty much all I had to show you concerning this. At this point, I could just render this out and then use this in the compositor and add some effects, maybe some glowing effects to get some light wrapping and do some color correction. I could actually do some color correction right here if I wanted to inside of the video sequence editor by adding some color correction add-ons, some modifiers. You can even add a few other effects, like I could add a glow effect to get some light wrapping. That's what I did in the second version of this scene that I put up on my YouTube channel. I just used the effects within the video sequence editor to do that. So you know, Blender's getting more and more powerful by the day, and you're able to do a lot more things with it now than you were just a few years ago. So anyway, some food for thought. OpenGL rendering inside of Blender. I hope you got something out of this tutorial, and I hope that you find this useful. And if you have any questions, you can certainly leave me a message or put a comment up on the video on my YouTube channel, and I'll get right back to you, or I'll respond to you when I get a chance. I hope you enjoy using this. So good luck and happy blending.